so for this video, we're going to talk about part number 5 on page number 6 of exam number 3, which talked about evaluating non-determinate limits using the L'Hopital's rule. So in this case, we have part A, part B, part C, and part D, and we're going to utilize L'Hopital's rule in order to find each limit specified here. So for the first limit, we have limit of x approaching to positive infinity. Sorry, this should be negative infinity actually. Limit of x approaching negative infinity of 3 of x minus 5 over square root of x squared plus 6. So when it comes to these types of limits, L'Hopital's rule is trying to find the limit, or to evaluate the limit when the limit expression is written in a non-determinate form. So some examples of non-determinate forms include, 0 over 0 or infinity over infinity. Some others include 0 times infinity and examples as such. So these are like some of the main examples that come when there are like non-determinate forms. So in this case, what do we want to do? So in this case, we want to first demonstrate that the limit is part of a non-determinate form. So we want to plug in the infinity into the expression. So it's going to be 3 times negative infinity minus 5 over square root of negative infinity squared plus 6, which in this case would just equal infinity over, this would be just infinity, and then this should also be infinity as well too. So in this case, we have a non-determinate form of being infinity over infinity. So what would we want to do next? So in this case, we want to rewrite the limit expression in such a way that it makes it easier for us to solve it. So in this case, what we can do is we can rewrite this as limit x approaching to negative infinity of 3x minus 5 over, we can take an x squared out of this whole equation, so we can just be, it would just be root of x squared times 1 plus 6 over x squared. So now we can rewrite it even further. We can simplify down, so we can write as limit x approaches to negative infinity, and then over here we just have 3x minus 5 over absolute value of x times the square root of 1 plus 6 over x squared. So now that we have that, what we want to do is, in this case, since we have the absolute value right here, we can just simply rewrite this. And since the x in this case is approaching a negative, this absolute value will turn into a negative. So we have 3x minus 5 over negative x times 1 plus 6 over x squared in this case. So now we can just move this negative from the denominator into the numerator, and we can just rewrite it as this. So it'll just be limit of x approaching to negative infinity of 3x minus 5, we should say negative 3x minus 5 over x times square root of 1 plus 6 over x squared. So now that we have this, in this kinds of situations, when it comes to non-determinate limits, it's one simple method in order to simplify the function is to multiply both sides of the fraction by the reciprocal of the lowest power. So in this case, the lowest power in the denominator is just x to the power 1. So we can just multiply that by its reciprocal, which just be 1 over x, and we do that over both sides of the fraction in this case. So now we just distribute evenly. So in this case, x cancels out, and we have here the x cancels out as well too. So we would just have essentially limit of x approaching to negative infinity of negative 3 minus 5 over x. All of that over square root of 1 plus 6x squared. So now that we have this final function, what we can do is plug this negative the negative infinity into the expression. So in this case, this would just be negative 3 minus 5 over negative infinity, and then all that over root of 1 plus 6 over negative infinity squared. So in this case, this just becomes 0. So in this case, we have negative 3 minus 0, or you can just say plus 0 because it's a negative, and then minus a negative, that's just a positive, over just the square root of 1, or just 1 in this case. So now that we have that, we can just simplify it even further. So that would just be negative 3 in this case. So this should give you the final answer. And then for part B, we have the limit of x approaching to infinity of sine x6x over 2x. So in this case, what we can do, we want to first again show that this is a non-determinate form. So we want to plug in the infinity into this. So in this case, we just do sine of 6 times infinity over 2 times infinity, which equals infinity over infinity. So now, when it comes to non-determinate forms, so whenever you get infinity over infinity or 0 over 0, this means that you can apply L'Hopital's rule directly to the fraction or to the limit expression, which means that you have to take the derivative of both sides individually, not rather as a function. So you don't have to apply the quotient rule in this case in order to find the derivative. So in this case, we can just apply L'Hopital's rule. So in this case, you have to write L, H equals the derivative of sine 6x versus cosine. Sorry, I'll write this properly. That would just be cosine 6x times 6, because we're applying the chain rule. So we want to first find the derivative of the trig, then we want to find the derivative of the inside, over 2x, which is just 2 in this case. So now we apply this even further. So you have 6 cosine of 6x over 2. So now we apply the infinity. So now we have 6 times cosine of 6 times infinity, which equal over 2. So in this case, this would just be this would just cancel out. So just cosine of 0 would just be 1. So we just have 6 times 1 over 2, which essentially simplifies down to 3 over 1, or 3 over 1, sorry, which is equals 3 in this case. So this should be the final answer for this expression right here. And for part B, we have the limit of x approaching to positive infinity of x over 1 over x to a power of 3 times e to the power of 2x. So again, we want to start off with non-determinate forms. We want to first show that this limit is a non-determinate form. So we want to apply the infinity into the expression. So in this case, we have 1 over infinity to the power of 3 times e to the power of 2 times infinity. So in this case, we have 0 right here, and then e to the power of infinity is just infinity. So and then e to the power of infinity is just infinity. So 0 times infinity is just, in this case, the non-determinate form that we have. But because this is not one of the main non-determinate forms where we can apply L'Hopital's rule directly to the function, that means that we'd have to rewrite this expression. So in this case, what we can do, we can combine these two together. So we can just rewrite this as limit of x approaching to infinity of e to the 2x over x to the 3, which means that if we apply this directly, we have e to the power of 2 times infinity over infinity cubed, which is just infinity over infinity. So now we have one of the main non-determinate forms that allows us to apply L'Hopital's rule directly. So in this case, we want to do is LH equals, in order to indicate L'Hopital's rule, and we want to find the derivative of both sides. So in this case, the derivative of e to the 2x, you just multiply e to the 2x times the derivative of the inside. So in this case, it would be e to the 2x times 2, because 2 is the derivative of the inside, over x to the 3, which is just 3x squared. So in this case, you can just simplify it down even further. So you have e to the 2 times e to the 2x over 3x squared. So now we apply the non-determinate form again. So we'd have 2 times e to the power 2 times infinity over 3 times infinity squared, which in this case just equals infinity times 2 is just infinity again, and then 3 times infinity squared is just infinity again. So that means that we have the non-determinate form again, so we apply L'Hopital's rule and find the derivative of the new term that we have over here. So the derivative of 2 times e to the 2x over 3x squared, so we find the derivative of both sides accordingly. So write LH to indicate they're applying L'Hopital's rule. So in this case, you have 2 times e to the power of 2x. So the derivative of that is just going to be 2 times e to the 2x times 2, because 2e to the 2x is just, it has its own special derivative, so it's going to remain the same, and then the rule of that specifies that we must multiply that by the inside derivative, but the derivative of the inside function, which is just 2 in this case, over 3x squared, which in this case would just be 6x. So now we have 4e to the 2x over 6x, and now we apply the limits once again. So we'd have 4 times e to the power of 2 times infinity over 6 times infinity, which again equals just infinity in this case, infinity over infinity, because 2 times infinity is just infinity, e to the power of infinity is just infinity, and 4 times infinity is just infinity in all cases. And then that over 6 times infinity, again, equals just infinity. Any number times infinity just equals infinity. So again, we have to apply L'Hopital's rule. Now we got to integrate that with the LH above the equal sign. And now we find the derivative again of this new expression that we have right here. So in this case, it would just be 4e to the 2x times 2 over 6. So this would just equal to 8e to the 2x over 6. So right now, if we apply the infinity, we have 8 times e to the power of 2 times infinity over 6, which in this case, this gives us 8 times infinity over 6, which just gives you infinity in this case. So this will result in infinity for part C. So now, I know it's a bit messy, but we gotta divide it in order to make sure that we can distinguish the two problems. So now finally for part D, we have a limit of x approaching to 0 from the negative side. This minus right here represents that it is approaching that limit from the negative side rather than the positive side. If it were positive, it would just be a plus sign instead of a minus. And then we have that limit of 1 over x squared minus 2 over 3x squared. So in this case, what we want to do is, again, show that this is a non-determinate form. So we want to apply this 0 directly into the expression right over here. So in this case, we'd have 1 over, sorry, not infinity. It would be 0 squared minus 2 over 0 cubed, which just equals infinity minus negative infinity in this case, because this would turn out to be negative because it's since this is a negative 0, it's to the power of 2, which is even, it will result in a positive, so this will be positive infinity, whereas in here we have negative 0 to the power of 3, which is odd, which will result in a negative in this case. So we have we have infinity minus negative infinity, which in this case just equals infinity plus infinity, because two negatives make a positive. So now we just add those two together, so infinity plus infinity just equals infinity. So this should be the final answer for part D. Thank you.